Hi, welcome back. So we are at the last outline of this section, and that is to discuss a practical case study where we can actually put all the information we have learned so far into one particular example. And in particular, we are interested to create or design a notebook application. Now, this notebook application we have worked on in the first chapter as a unit exercise where I have actually asked you to do a kind of a design for a notebook inspired by any of the notebook that comes by default in any operating system. Now, as I said, this practice, you will use a common example of creating the class, the attribute, behaviors, function, doc string, also perhaps structuring the file of your project, etc. And it's a good initial start to actually apply the analysis, design, and finally the code. So let's ask the question, what does notebook mean? So it seems there's like a kind of you could call it a book, and inside that book, there are a number of notes. So I would have like note 1, note 2, and so on, note n. So the question is that if I look at this from abstract perspective, I would observe directly that this notebook entirely, it's considered to be an object. And perhaps each one of these notes is also considered to be an object. So we have here just from these two pictures, I would just extract two objects that perhaps could be like a blueprint for a class. And the second thing, maybe from the abstract of the language, I would ask what operations that I might do either on the notebook or the note itself. Another question about the relationship between the note and the notebook. So first of all, let's look at the note. What you expect from the operation that you expect on this case. Of course, you want to add a new note. Maybe you want to modify a note. Maybe you want to search. Maybe you want to delete, something like that. So what kind of attributes? Well, each note might have an ID, might have a name, might have a memo. I mean, the actual text, etc. These are the attributes that you can expect. Same for the whole notebook. So I leave this for you to actually go through the analysis part and try to practice. I assume you have done that in the first chapter. Now, for the design part, as we said, maybe we can move to use some kind of UML here to translate that text into some kind of practical thing. So here I introduced you just as an example of having a note kind of object class. And then I start to look at the side of the attribute and the side of the behaviors. So in the attribute, maybe I expect every node to have the memo and to have a date and to have its own ID. Maybe later I could use that ID for some purposes of unique node. And then I have the behavior of each node. Well, I just supposed to have a matching, which accept a string and return a string. So basically, if I'm looking for a note, it can receive whatever you want and return for you a string. And this string can be actually the note itself or can be just the memo of the note. And then the next class I designed to be the notebook itself. So in the notebook, I said, well, I have here one attribute. It's more than enough. I imagine the notebook is just kind of a list, right? And you add the notes inside just the picture I drew in the beginning. And these are a number of behaviors that the notebook is operating. So you can add notes inside this notebook, which can you see that it receives a string, maybe the memo. You can find a note. And it return, in this case, a note you see of that type of class. So now start with link between them. You might modify a note based on an integer, the ID of the note, and whatever the new text could be, search a note, something. So I keep things simple and easy. Now the last question, what kind of relationship between them? Well, we saw this represent a composition, right? One of the fourth element we learned about encapsulation, inheritance, polymorphism, and composition. So we know the notebook actually is composed of number of nodes. If those nodes or the notebook is deleted, the entire nodes will be deleted as well. That's why I use this kind of a composition relationship. Otherwise, could be just only an aggregation. Please go back to UML and check what does that mean. Finally, I added this kind of interface. Well, this is an entry to the idea of modules and packaging. So how I'm going to write this, or what kind of structure I'm thinking about? Well, under kind of the main package, maybe you could call it for now, or the project name, main project name, I will just maybe add two modules, not more than that. One module contain this object, right? This is module 1. And the second module is just for this interface. So the interface will be interacting here. So this is going to be the back end and this is going to be the front end, so to speak. So the final thing maybe would be looking like this. This is the Note app, and then you have just only menu and notebook. So if I start writing the code and translate everything into practice, my code would look like something similar to that. I'm going to take you now to the actual visual code and I'll show you what are the details of this. So here I use a doc string. You can see I just follow every ID that I was talking about before. So I created the class node based on the UML that I have just shown you by creating these kind of attributes, and I start to create the relative kind of behaviors. Same thing, I did maybe another class for the notebook, same thing, and both of them were inside one module. And finally, for the interface, which has its own class as well, maybe later I would use the dunder if the name is equal to main. Remember to just only use one function to run instead of just keep it open access. So this is a suggestion of the way that I like to organize and start exercising that. So I leave that for you to create your own. I'm going to share that in the GitHub, a relative kind of chapter 2. Let me take you quickly to the code and show you how we did that. So I moved back here. I had these two modules, right? Notebook and menu, just like I did before. So inside the notebook, I have started by creating the note class. And then under that is just inside the same module, the notebook class. So we have two classes. Now inside the notebook class, of course, I just make the initializer after the doc string here. And every time you need to initialize a note, you must provide me with a memo. And memo, it represents what actual note you want to do. And then I create this class variable, I call it self.memo, and I just store whatever you give it me. And then the next attribute I added is the date, right? And that's why I used here another library, external library, which is called the datetime. And I just add the date and the following time. You can check this library and its documentation. It's really valuable one. And then after that, I want to add ID for every node. So one ID I thought about, well, every time I add node, I want the number to increase. Of course, this is just going to be increased on one run of the memory. If we are working in a proper kind of a production, of course, it's going to be connected to a database. So the data will not be deleted if I run the application again. But for now, just illustration purpose, I turned out into 0. And you can see I put it in a global kind of access. We talk about private and global kind of a variable, right? And I set it to 0. And I started to say, well, I want you to reach to the global last ID. And once you initialize an object of node, I want you to add 1 to this. So I start to increase 1, 2, 3, etc. Now, all this information would be actually related to the object that I have initialized for the node. And then I have one behavior only. I call it match, accept kind of a string. You could see it returns here if this string has any match in the memo that you actually have provided before. Now, this is the actual structure for node class, but of course it doesn't work on its own. That's why we have to create the big things which is called the notebook. This is the actual engine, the logic of the application. So once again, it's a class. I create its initializer. I look inside the initializer, only one variable that's of a type list, and I call it notes. So that's why it's called notebook. So it's an empty list. It's obvious now I will start to attach object of notes here. So I will have the first object, the second, and each one of these objects represent one of these notes. How to add a new note? Simple. You give me the string. After you do that, I'm going to take actually the self node, which is the list, and append to it what? Now I'm creating an object. You see, this is an object and I'm passing memo to it. So remember the notes, it just will take here and start to create the string, the date, the ID, etc. And then it's returned back, and whatever I have now, a new object of note, I will be appended to here. This is the idea, simple. Also, the notebook have an ability to search or to find something. So in the search method, in a simple way, you give me a string, I will take that string, and what I'm going to do, try to find if this string exists in any of the nodes that I have. and whatever list of those nodes contain the string you give me, I'm going to return back to you. That's why I use something called the comprehension in Python. I think we're going to be talking about that sometimes later, but you should have an idea. So the idea of comprehension is, say, it define a variable called node and it go and start looping inside somewhere. So I define node and I say node is going to be actually where looping inside the self of node. So now I am inside this initial list. And I want to retrieve from this list every, based on one condition. What is the condition? If I take that node, dot match, and don't forget the match here, it is a built-in behavior inside the node, this one here. So because I'm passing literally the filter to it. So I'm going to pass that text. If you find text matching the node, we'll return that object as it is and put it inside the list. After you finish, just return that list of matching, depends on the string. For modifying things, modifying a node, I request 2 arguments. Give me an ID that you want to modify which node, and what is the new string you want to put. So here I'm taking that and just making sure. Now, I want you to look carefully, where is this function? I use privacy here, kind of internal use only. I define a function called find node. What does find node does? It just takes an ID, and then it goes to the self nodes, which is the list of all nodes. It checks if this ID exists or not. If this ID exists, it will return that object as it is. If it is not, it will return nothing. So this define node is just for a quick, small operational purpose. And I did that to encapsulate and can be reused in so many different places, not only for the purpose of modification. I could have used it for search, customization, and some other purposes. So this kind of technique, it's very nice and give you a string ability from object-oriented perspective. I will take this object that you have just returned to me, right? This is the object that's returned because it's going to return the node. And I'm going to go inside that object, in particular, it's memo. And the memo, remember, it's one of the particular object of node. And what I'm going to do next, I will just add the text you make it. Else, I would say, well, there's no matching ID. This is the 2 main classes that do all the job for us. Now, what is inside menu? Well, this is the interface. The first thing it initializes once I run menu, it should initialize an empty notebook object. That's why I imported here the notebook. You see, I imported node to show you I don't talk to node at all. The actual one I'm talking to is just notebook. That's why you can see the color are different here. Now I have created dictionary, this is a form dictionary. I have a key and a value. So what's the key is 1, and what's the value is a function. So I create another function called display menu, which basically just make a print. Now I have a function called run, and this run will be the actual function that will be connected to this entire class. So basically, I'm not gonna run this module and it will just go and run everything. It will only run this function. And what's this function have? A control flow called while. So this application will keep running as long as you don't hit a specific condition. So why true? I want to display the menu, which is this guy here. And then I'm going to take a variable called choice, which is just an input from the user. So again, enter an option. So you're going to enter 1 to 5. If you enter any other number, I will give you this message by saying it's not a valid number. But if it is valid from 1 to 5, what I'm going to say, I will take that action and I will add to it this. So it means if you enter 1, he will go to the value of 1. That's why I'm making the condition here. Go to self.choice.get, which is built-in function of a dictionary. Check that in your own. And I'm passing, if it is 1, so you go and check, is 1 is in there? Yes, it is. Then he go and pick this particular self.showNotes. But self.showNotes, it should be acted as a function. Now that self.showNote, it should be written down here. That's why we have show notes, we have search notes, and etc., etc. So in the show notes, you could see very clearly, I'm defining here default value. We spoke about it before. And I'm saying if it is none, just initiate. It means nothing to show. Just give me an empty note. Otherwise, I want you to loop inside whatever an existing node, extract the ID, and display the memo of it. Search node, I want you to take from argument from the user what he's searching for, and then go ahead and pass to the search inside the notebook. Remember here all the functions we're talking about. So in the search, you go to the search function. In the add, you go to the new node. In the modify, you go to the modify memo. In a quit, just quit the application. And after you write this class, right, the menu class that I was talking about, I'm not going to just run it directly. I will just use this. If this is run from the main, what I want you to do, I want you to go and run this particular method here. Let's go and try to actually run this application, so what we'll have. So the first thing I will encounter is the menu that we had just drawn here. Let's add a note, my first note. Now your note has been added successfully. Let's try add one more note. I will write this time note by mistake. Now let's go to one again and show these are the notes that are available. So we got note 1, note 2, etc. Modify one of these notes. So I would go to number 4 to modify. You say what is the ID of the note you want to modify? Let's say number 2, and say what is the new. I would say my second note, not note. So we say, okay, it's been successful. Let's go and show again. And you can see now my second node has been modified. And then 5 just to quit. Last thing before we close down completely on this section, this is a unit exercise. I leave it for you to check it down out. So I want you to try to do application. So to do application, which would be similar to the design of the notebook application, but with an extra date management method, so to speak. Try to unleash your imagination and unlock the particular idea behind everything. Now we have reached to the third section of this training program, and